So, what do a rocket scientist, a legendary inventor, a tech visionary, and a Nobel Prize-winning physicist all have in common? It sounds like the start of a joke, right? But they all mastered this incredible way of thinking to solve problems that seemed, well, impossible. It's called first principles thinking, and in this explainer, we are going to break down exactly how they used it to completely change the world we live in.
All right, welcome to Chapter 7, where we get into the really fun stuff, the real-world examples of first principles thinking. This course, by the way, is brought to you by Venture.com Academy. We're super excited to dive into some of these incredible stories with you.
So, here's what we've got on tap. We're going to look at 4 amazing case studies: Elon Musk, Thomas Edison, Steve Jobs, and the brilliant Richard Feynman. We'll see how each of them used this way of thinking, and then we'll wrap it all up with the big takeaways. Let's get into it.
First up, the modern disruptor himself, Elon Musk. We're going to look at how he completely upended the space travel industry. And the key is, he didn't just try to make existing rockets a little bit better, he rebuilt the entire idea of what a rocket is, right from its most basic truths.
To really get what Musk did, we first have to understand the assumption he was up against. I mean, for decades, the entire aerospace industry operated on one single, very expensive belief. So what was that common wisdom everyone just accepted about rockets?
On the left, you see what everyone thought. Rockets are just expensive, period. That's the way it is. It was treated like a law of nature. But on the right, you see Musk's approach. He totally ignored the final price tag and asked 2 way more fundamental questions. First, what are these things actually made of? And second, why on earth can we only use them one time?
And you know what? The answers he found were just mind-blowing. First, the materials. He did the math and found that the raw materials to build a rocket were only about 2% of the final cost. The other 98%? That was just layers and layers of inefficient process. And then, reusability. He realized throwing away a rocket after one use was completely insane. It's like building a brand new airplane, flying it from New York to LA once, and then just junking it. It makes no sense.
And the Falcon 1 launch was the proof in the pudding. By building a solution from those basic truths, Musk didn't just build a cheaper rocket, he redefined the standards for an entire industry. It just goes to show you, the biggest breakthroughs, they don't come from tiny improvements. They come from asking a fundamentally better question. All right, now let's jump in a time machine and go way back to the 19th century and meet another master of this method, the relentless inventor Thomas Edison. His quest for the light bulb is a perfect masterclass in first principles thinking. See, Edison wasn't trying to make a better candle or a slightly safer gas lamp. No, he started from absolute scratch. He asked a much bigger, much more basic question. How do we create a brand new source of light that's safe and practical enough for every single person's home? And here we go again, you can see that same critical difference in thinking. The normal approach was just, hey, let's make gas lighting a little better. But Edison, he went back to basics. He figured any electric light needs 2 fundamental things: a material that glows when you run electricity through it, that's the filament, and an environment that will let it glow for a really long time. And his dedication to this process was just incredible. He famously tested over 6,000 different materials to find the right filament. Think about that. He wasn't just guessing, he was systematically exploring the basic principles of material science. And that same process led him to another basic truth: things burn out because of oxygen. So, what's the solution? Well, get rid of the oxygen by creating a vacuum inside the bulb. Simple, right? The result of all that grinding, first principles work, was the practical, long-lasting light bulb. And it wasn't just an improvement, it was a fundamental shift that literally lit up the modern world and completely changed how we all live and work forever.
Okay, our third case study, Steve Jobs. Now, he applied first principles thinking not to raw materials, but to something a bit more abstract, but just as powerful: the user experience.
While the rest of the tech world was obsessed with cramming in more features, more buttons, more specs, Jobs was asking a completely different question. He was asking, what does a user truly want? What's the most essential, most intuitive experience we can possibly create?
And the difference was just night and day. The common belief back then was that good tech looked complicated. More features meant it was better. Jobs completely rejected that idea. His first principle was that technology should be simple. It should serve the user, not make the user work harder. The goal wasn't complexity, it was radical simplicity.
So he broke product design down to its core. First, the user's experience. He would ask, does this feature actually help someone, or does it just create clutter and confusion?
And second, simplicity in design. He challenged that core belief that a complicated-looking machine was somehow superior. For Jobs, real power came from elegance and simplicity.
And this obsession with the user's core needs led directly to things like the iPod and the iPhone. I mean, they weren't the first MP3 players or smartphones, not by a long shot, but they were the first ones built from the ground up on the principles of beauty, function, and just being incredibly intuitive. And that is why they didn't just compete, they transformed entire industries.
Okay, for our final example, let's talk about the brilliant physicist Richard Feynman. He applied first principles not to building things, but to the very act of understanding and explaining how the universe works.
Feynman was famously obsessed with one question that really drove his whole life's work. How can you take the most complicated, mind-bending ideas in physics and explain them so simply that basically anyone can understand them?
The common belief, especially in the academic world, was that some things are just, well, they're too hard for most people to get. You just have to accept the complex theories. Feynman thought that was total nonsense. His first principle was simple. If you truly understand something, you can explain it in simple terms. If you can't, you don't actually understand it yourself. So his whole method was a 1-2 punch. First, he demanded an absolute mastery of the basics. Don't just memorize the fancy formulas, deeply understand the foundational physics. And second, he had this relentless curiosity. He was famous for constantly asking why, but why, but why, just peeling back every layer until he hit the absolute bedrock of an idea. And this very approach led him to create things like his famous Feynman diagrams. By breaking down super complex particle interactions into these simple little drawings, he made these profound ideas accessible to everyone. He proved his own point. True understanding leads to simple explanations. And in the process, he totally reinvented how physics was taught.
So what's the big takeaway here? When you look at all four of these giants, what's the common thread? First principles thinking. It's not really about being the smartest person in the room. It's a process. It's about having the guts to question the assumptions everyone else takes for granted. It's about breaking problems down to their most basic parts. And maybe most importantly, it's about flat out refusing to accept the phrase, well, that's just how it's always been done, and then building something new from the ground up.
Musk, Edison, Jobs, Feynman, they show us just how unbelievably powerful this way of thinking can be. If you want to dive even deeper, we've got quizzes, notes, and a cool infographic for this chapter waiting for you. Just check out the link in the description or head over to bventure.com. And when you're ready, join me for Chapter 8, where we'll explore how to use constraints to spark your own breakthroughs. Thanks so much for watching.